Assalamualaikum, very good morning students. So today I am Dr. Shafiq Fauzi Kamaruzaman delivering you another module of Data Communication and Networking. I would like to express my appreciation to all of those who stay with me until this video for our Data Communication and Networking course. So hopefully you will keep looking forward to the other videos that I will create later on until the end of the course. So for those who have subscribed for my channel, I would like to say thank you for your subscription. And for those who haven't, please do subscribe. And I would really appreciate if you could drop by some likes in my videos. So let's start the class. Okay, our topic for today is under chapter module 13 under ICMP. So ICMP is actually not that rare or not that so can I say foreign to any of you who experienced with computer network before, because this is the basic fundamental of what we have we call ping. So let's take a look on the content. Okay, so what exactly is ICMP messages? Okay, so ICMP, we have two types of ICMP messages, which is under ICMP version 4 and ICMP version 6 messages. So all of this, they comply to what we have, the IPv4 and IPv6. So ICMP stands for Internet Control Messaging Protocol that provides feedback about issues related to the processing of IP packets under certain conditions. So this is where we have this ICMP in. So ICMP v4 is the messaging protocol for IPv4. So ICMP v6 is the messaging protocol for IPv6 and includes a little bit of additional functionality as well. So the ICMP messages common to both ICMP v4 and ICMP v6, they include three things basically. So the first one is host reachability, so whether you can reach the host or not. And then you have destination or service unreachable. Okay, so this one is kind of like a status that be replied based on the ICMP protocol. So and then time exceeded, how far where the time exceeded since the last message given. So all these things, if you conduct a pig test to any computer through a network, you will see this kind of information provided for you, and this ICMP protocol. So this ICMP version 4 messages, they are not required and are often not allowed within a network for some security reasons. Okay, like for example, you have problem related to spoofing or anything else related to security of the network. So let's take a look about the host reachability. So basically, okay, ICMP echo message, they can be used to test the reachability of a host on an IP network. So in case you look at the slide here, you have this PC, okay, H1, okay, so is H2 reachable? Okay, so if you will check based on the echo reply, and the H2 reply, yes, I am here. So in this example, what it means is that the local host send an ICMP echo request to a host. If the host is available, okay, the destination host responds to the echo reply. So basically, it's just a reply, it's an echo. You send something and then it reply the same thing. Okay, so this is where a host reachability is confirmed. So then we have, okay, destination or service unreachable. Okay, so an ICMP destination unreachable message can be used to notify the source that a destination or service is unreachable, basically. So if the ICMP message will include a code indicating why the packet could not be delivered. So there are several reasons of the reason in case why the packet cannot be delivered. So this is based on the code. So for example, in ICMP v4, okay, you can see the slides say that 0 is network unreachable, 1 is host unreachable, 2 is protocol unreachable, or 3 is port unreachable. Anyway, on ICMP V6, we have 0 for no route to destination, 1 communication with the destination is prohibited, like for example fireball. Okay, number 2 is beyond scope of the source address. Okay, and then number 3 is address unreachable, number 4 is port unreachable. Okay, so almost similar in terms of ICMP V4 and V6. However, ICMP V6, okay, they are slightly different code from for destination unreachable message. Okay, so next is for time exceeded. Okay, when the time to live, okay, TTL field in a packet is decremented to 0, an ICMP v4 time exceeded message will be sent to the source host. Okay, so you can check the time exceeded messages, okay, by the Traceroute tool. Okay, ICMP v6 also they send a time exceeded message instead of IPv4 TTL field. So ICMP-v6, they a little bit different. They use the IPv6 hop limit field to determine if the packet has expired. So basically, this is what you get for the time exceeding. So here, if you have some ping test in your PC for a network host, okay, you will get this kind of reply when you ping certain IP address. Okay, so they have TTL involved that provide you whether the data can be transmitted and received. Okay, so usually they send around 4 times. Okay, and then it confirm that there are no losses. So for ICMP v6 messages, okay, so ICMP v6, they has new features and improved functionality that is not found in normal ICMP v4. So this including 4 new protocols as part of the Neighbor Discovery Protocol. Okay, usually we call it as ND or NDP, Neighbor Discovery Protocol. So messaging between an IPv6 router and an IPv6 device, okay, they include dynamic address allocation, which is router solicitation message, and router advertisement message, okay, RS and RA. So messaging between the IPv6 device, okay, they also include the same thing like the router. However, they call it as, okay, they include the duplicate address detection and address resolution, which is called as neighbor solicitation message, which is called NS, and also neighbor advertisement message, which is called NA. So for router, basically you have RS and RA. For devices, normal devices, you have NS and NA. Okay. So network discovery, okay, for ICMP v6, okay, they also include the redirect message, which has a similar function to redirect message used in ICMP v4. Okay. So as example here, okay, you see that this is in the case of ICMP v6. Okay, so the RA message, okay, they are sent by the IPv6 enable routers every 200 seconds to provide addressing information to IPv6 enable hosts. Okay, so they will send to provide addressing information for this router. So the RA message can include addressing information for the host such as prefix length, DNS address, and domain name. Okay, so a host that uses stateless address auto configuration, which is SLAC, will set its default gateway to the link local address of the router that send the RA. So actually, so for this router, it will send the RA message so that all the hosts know that he is the default gateway. So anytime that they want to send any messages, so they will acknowledge R1 as their own default gateway. So in this case, okay, an IPv6 enabled router will also send out an RA message in response to an RS message. Okay, once they send the RS message, next they will send, okay, they will receive an RS message, they will send an RA message. Okay, so in here you see that PC1 send an RS message to determine how to receive the IPv6 address information dynamically. So in this case, R1 here replies to the RS message with an RA message. So RA is basically a reply for RS message. Okay, so PC1 says an RS message which is, "Hi, I just boot up. Okay, so is there an IPv6 router on the network? I need to know how to get my IP address information dynamically. So I haven't know anybody in the network yet." So the R1 will reply with an array message. So, "Hi, all IPv6 enabled device. I am R1 and you can use Slack to create an IPv6 global unicast address." So the prefix is this address, which is the gateway of the address of this router. And in case you are using my link local address, okay, so this is your default gateway. Okay, use the link local address as your default gateway. Okay, so this is one of the things that happening between the RS and the RA. So let's continue. Okay, so a device assigned a global IPv6 unicast or link local unicast address may perform duplicate address detection, okay, which is DAD, okay, to ensure that the IPv6 address is unique. So this is for security purposes. So when they have, okay, they have a link local unicast address, they can check with another PC whether they have the same unicast address or not. Okay, so to check the uniqueness of an address, the device will send an NS message with its own IPv6 address as the targeted IPv6 address. Okay, so if another device on the network has also the same address as this PC, okay, so if they have the same address, it will respond an NA message notifying to the sending device that the address is in use. Okay, so this one is basically from the host. You send an S to check whether the other PC has their IP address or not, and the other PC will reply an NA message telling that this PC whether they are using the same IP address or not. So basically, RS and NS is the beginning, and RA and NA is the reply form. Okay. Okay. So here in this case, let's take a look. Okay. So in this case, let's check your understanding. So determine the MAC address for the destination. Okay. To determine the MAC address for the destination, okay, the device will send an NS message to the solicited node address. Okay, so they will send this NS message. The message will include the known targeted IPv6 address. The device that has the targeted IPv6 address will respond with an NA message containing Ethernet MAC address. Okay, so in the figure, R1 sent, okay, an NS message, okay, to this IP address asking for its MAC address, and this PC will reply this message with his own IPv6 address and its own MAC address. So it's not that difficult, okay, about the RA, RS, and A, and RS and S, RS and A, and NS and A within the network. So, in order for us to confirm whether in your network the computer works perfectly or not, so we have what we call a ping and traceroute test. So what exactly ping? Okay, so the ping command is an IPv4 and IPv6 testing utility that uses ICMP echo request and echo reply messages. Okay, testing utility that uses ICMP echo request and echo reply messages to test the connectivity between the host and provides a summary that includes the success rate and the average round trip time to the destination. So it's actually they use ICMP echo request and echo reply to test the communication, which we often know as ping. So if a reply is not received, sorry, if a reply is not received within the timeout, so ping provides a message indicating that a response was not received. So you see that, like for example, no success rate, there are several messages that was not received yet. So this means some kind of error in your network. So it is common for the first ping to time out if address resolution, which is ARP or ND, need to be performed before sending the ICMP echo request. Means that if the PC doesn't know about the existence of your sending PC, okay, you need to store the information of your address first. So that's why kind of the first ping might be a little bit timeout, and they will continue on the second or third ping. So this is common with the ping test. So ping you can also use to test your PC connection. So this is based on the ping, the loopback. Okay, so ping can be used to test the internal configuration of IPv4 and IPv6 on a host, okay, on a local host. Okay, so to do this, the ping, okay, to do this, ping the loopback address, which is 127.0.0.1, means not pinging your own PC address, but loopback address. Okay, this is for IPv4, but we have for IPv6 is simple, double colon 1. Okay, just 3, double colon 1. Okay, and a response from 127.0.0.1, okay, or double colon 1 for IPv6 indicates that the IP is properly installed on the host. Okay, so in this case, an error message indicates that TCP/IP is not operational on the host. Okay, so this is one of the issues that you can solve using the loopback by pinging the loopback address. So and then you can ping the default gateway to test your network as well. So the ping command can be used to test the ability of a host to communicate on the local network. Okay, you can ping the default gateway. So the default gateway address is most often used before the router is normally always operational. Okay, so a successful ping to the default gateway indicates that the host and the router interface serving as the default gateway are both operational on the local network. So if the default gateway address does not respond, a ping can be sent to the IP address of another host inside the network that is known to be operational. So just in case you want to confirm whether the default gateway is operational or not. Okay, this one is I think the most common thing you do in your network activity, which is ping a remote host. Okay, so you can ping. Okay, you can use ping. Okay, to test the ability of a local host to communicate across an inter-network. Okay, you have an inter-network, you can ping anything. Even now in your PC, if you have a Google server address with you, you can ping a Google server address as well. Okay, so a local host can ping a host on a remote network. So a successful ping across the internet network confirms communication on the local network. So okay, so many network administrator limits or prohibits the entry of ICMP messages. So therefore, the lack of ping response could be for the security reason. So you can try and ping a Google server, you have a Google IP address that you can try and ping, and then you get the response. Okay, so you can test this with your own PC later on. So then we have what we call a traceroute. Okay, traceroute. So traceroute, the command is, okay, TRACERT. Okay, so it's basically is a utility that is used to test the path between two hosts and provide a list of hops that will successfully reach along that path. Okay, so so traceroute provides round trip time for each hop along the path and indicates if a hop fails to respond. An asterisk, usually you have an asterisk, okay, they use to indicate a loss or unreplied packet within the messages. Okay, so this information can be used to locate a problematic router in the past, or may indicate that the router is configured not to reply. So this is a way for us to check whether the route of your network is okay or not. So Traceroute, they make use of a function called TTL field in IPv4 and the hop limit field in IPv6, okay, in the layer 3 headers. So along with the ICMP time exit messages, okay. So Traceroute, they have all this function involved inside the command. So in case you want to test traceroute, like for example in this case, traceroute 192.168.1.2, okay, so here you're tracerouting this PC, okay, TTL4. What does it mean? Okay, so the first message sent from traceroute, okay, will have a TTL field value of 1. This caused the TTL to time out at the first router. Okay, this one we have the first router time out. So this router then respond with ICMP v4 time exit message. Okay, so you reply again. So this is 1. Then it will continue, and then this is 2, and then this is 3, and up until the end is 4. Okay, for each sequence of the message. So this provide the trace with the address of each hop as the packets timeouts further down the path. Okay, so the TTL field continues to increase until the destination is reached, or it is incremented to a predefined maximum. So if you limit the maximum, then it will be the maximum. If it's more, it will continue up until it reach the end of the network. So you can see that the count is here in this case is 4. Okay, so I guess that's all for this module. So this is a short module which is under ICMP messages. So thank you again for your attention on my class videos. So hopefully you will continue with me on my next video. Please do subscribe and leave a like button in my videos. Okay, so therefore I'll see you guys next time in my other video. So stay safe and have a nice day. Bye bye.